Okay, comparing and interpreting rates. Okay, so this unit 8, is on proportional reasoning, right? We're going to start today with 2 lessons, one on comparing and interpreting rates, and then the other one on solving problems that involve rates, right? And rates are things that we use in life, right? I mean, if you talk about the mileage that your car gets, you're using a rate, so many liters per 100 kilometers. That's a rate. We talk about the rate at which the temperature is changing. You know, a Chinook comes in and the temperature goes up. We could say it rose by, 10 degrees Celsius per hour. That's also a rate. All right, graphs below are Simon Whitfield's times for the 3 legs of the triathlons in which he competed during 2 different Olympic Games. 3 legs of the race include a swim, followed by a bicycle ride, and finishing with a run. And here's Simon's race in Sydney and Simon's race in Beijing. In 2000, 2008. Determine each of the following. Simon's swim speed in both races. Okay, so a speed is distance divided by time, right? And you'll recognize that as the slope of the line, right? As we did slope in. So you want the slope of this line. You could see that it took 18 minutes and 17 seconds to go 1.5. Done in, that must be what, 15 minutes? What is that?
1.5.
Oh no, that's the time. And the distance, so, got these wrong. So the rate is distance, it's the y value, which is 1.5 kilometers, divided by 18 minutes, 17 seconds. Okay? And Simon, so this was the speed for Sydney and the speed for Beijing of swimming was, it's the same distance, right? Because triathlons, Olympic level triathlons are run, everything's done over the same distances, right? It's a 1.5 kilometer swim, a 40 kilometer bicycle ride, and a 10K run, I guess. And 1.5, 18:45. So 18 minutes, 45 seconds. Okay, so that's minutes. Minutes. Simon's running speed in both races. So for running speed, the run is here. So we need this distance, right? So it's 51.5. So Simon's running speed, so his speed in Sydney is 51.5 minus 41.5. So that's the change in y, right? Delta y over delta x. Okay. Change in the y values, right? Which is the definition of slope, right? Slope is y2 minus y1 over x2 minus x1. And the slope in this case is the speed, right? And speed is distance divided by time. So just, if you're not sure about the speed formula, just think about driving to Edmonton, right? It takes like about 3 hours to get to Edmonton, and it's 300 kilometers. And you know that you should be driving around 100 kilometers an hour. So, if you put those 3 numbers together, you'll figure out that speed is distance divided by time, right? 300 kilometers divided by 3 hours is 100. That's your speed, kilometers per hour. And at the bottom here we have 107.58. Oh, sorry, that's we're doing this one. 107.24 minus 77.28. Okay, and the speed for, let's do this here. So the speed for Beijing, speed little b for Beijing is 51.5 minus 41.5 over 107.58 minus 78.10. Okay, so we actually need to do something with that, right? We need to get a number for it, so we have to do some calculation. And of course, one problem we have here is that we're yeah, numbers are on your graph, right?
It's 41.5. Wait, no.
Okay, so this is 10 kilometers. So the run was 10 kilometers divided by, so we've got 107.24 minus 77.28. So how do we do that? What's that? So we get to track times, right? Times are wonderful because it's not a decimal, right? Decimals would be easy to subtract. It's minutes and seconds. And this one is smaller than this one, right? So we have some work to do here, right? So I'm going to do this up here. So I'm going to make it 1:06, and I'm going to add an 84 seconds, right? So 107 minutes, 24 seconds is 106 minutes and 84 seconds, right? Just take one away from there, but I got to put 60 on here, right? Because it's 1 minute and seconds. And then we're going to subtract 77:28. Okay? Now, we have to do this separately. We'd have to do 84 minus 28, just the difference in seconds. So what I couldn't do is put a 24 here, right? Because how do you have -4? So you can't have -4 seconds, right? So we had to borrow, right? It's like when you first learn to subtract, right? We borrow one from this column, we move it 10 over there. In this case, we're borrowing one of these minutes, but it becomes 60 seconds. Okay, yeah?
No, but why did you take out one? Sorry, you were just explaining.
Okay, so if I tried to write 107:24 minus 77:28, I can't subtract 28 from 24, right? Okay, so I borrowed 1 minute from here, and 1 minute is 60 seconds, so I added 60 to this. That gave me the 84. Okay, now I can subtract. So what's 84 minus 28? That's 84. 56, right? So 56, and 106 minus 77 is 29. Okay, so it's 10 kilometers in 29 minutes 56 seconds. Over here, we got 107:58, and we are subtracting 78:10. So it's okay, I can do that, right? Because this is bigger. So I get 48 seconds, and 107 minus 78 is 29. So we got 10 kilometers in 29 minutes 48 seconds, right? 29:48. Okay. So where did he swim faster?
Beijing. Oh, sorry.
Sydney. Where did he run faster?
Beijing.
Beijing. Which is amazing considering the air quality of Beijing. But I mean, running depends on the course, right? Like how many hills there are and stuff like that. Swimming depends on the water. So are you in, sort of a man-made lake where it's fairly calm? Are you in more open water where there's currents and stuff? So those times will vary, right? Same with the bicycles, right? So unless you're on the exact same course, under the exact same temperature, sun, wind conditions, and whatever, you can't make direct comparisons, but you can see it's pretty darn close, right? Okay, so the speed at which Simon swam and ran is called a rate. A rate is a comparison of two amounts that are measured in different units, right? So kilometers per minute, different units. Examples of rates: 5 kilometers per hour, 120 words per minute, 42 pounds per square inch, $3.99 per 100 grams. 3 of the above rates are called unit rates. A unit rate is a rate. We haven't skipped ahead. No, that's good. Okay. A unit rate is a rate in which the numerical value of the second term is a 1. So which of these guys are unit rates? Is this a unit rate? Is this a unit rate?
Yes.
Yeah. Actually, let's just circle them. Is this a unit rate?
No. Yes.
Yeah, because it's per 1 square inch. Is this a unit rate? No, because it's per 100 grams, right? So, not a unit rate. Convert the non-unit rate to a unit rate. So how do we make this into 1 gram? Divide top and bottom by 100, right? So we've got $3.99 per 100 grams, right? So if we divide by 100, divide by 100, we get $0.0399 gram.
Just happy to open.
Right? Now what we might do then is convert this to 3.99 cents per gram, right? Go from dollars into cents. Makes sense. Get it? Yeah, good. Yeah, Tuesday morning or so, that's good. You're gonna miss this. Admit it.
How can you have like 0.9 of a cent?
It's a base point.
Well, because you're not gonna buy 1 gram, right? And they'll round. Just like we round change now, right? It's rounded to the nearest 5 cents. Right? So depending on, unless you're paying by electronic means, in which case it is what it is. One store sells a container of 650 grams of yogurt for $3.95. While another store sells a 500 gram container of the same brand of yogurt for $3. Which container is the better buy? Determine the answer using 2 different methods. Okay, so told you this real life math, right? It comes in. Now a lot of times they'll put a rate comparison on the price tag. So if you look on the price tag, it'll give you a price per 100 milliliters or something like that. So you can compare 2 different brands. But maybe they don't, and then you got to do your own comparison. So unit rate. Okay, what we want our unit rate to be is dollars per gram. Okay, dollars per gram. So we put the dollars up top, right? We've got $3.95 for 650 grams. How do we convert that to a unit rate?
We don't have this.
What?
We have like, we have the top part, but we have no method to.
No. Don't worry about it.
It don't matter.
You can write in method 1 unit rate, and then you can write in method 2. You can put those words in. I trust you. I trust in your ability to copy like a 15th century monk, sitting there, illuminated by candle with his quill in hand. Darn, I made a mistake, and they didn't have whiteout back then. So. Which was invented by the mother of one of the monkeys. So there you go. Whiteout. Okay, so how do we get $3.95 for 650 grams into a unit rate? What do we do?
Divide it both by 650.
Okay, divide both by 650, right? Okay, so what does that work out to? Say it a little louder, please. How much? 0.00607. Okay, so 0.00607, right? And then there's more. We could put ... And we want the other price, right, which was $3 for 500 grams. Okay, so $3 for 500 grams. So what do we do to get that to a unit rate?
Divide both by 500.
Yeah, divide both by 500, right? Okay, so what does that give us? 0.006. Okay, so which one's cheaper? This one or this one?
Same.
Bottom or the top? Bottom, not by much, right? 0.07. More. But if you were buying like thousands of kilograms of this stuff, right, then that would make a difference, right? So you're a manufacturer and you go to 2 different dairies and they say, okay, here's our price. And you say, okay, well, hang on, this, I'm going to buy 1 million kilograms. I'm going to save some substantial money buying this one over this one. Method 2, converting each to a rate with a common denominator, right? So a lot of times what you'll see in the stores, they'll convert it to dollars per 100 grams, right? Because you really don't want to see 0.00607, right? So if we make it dollars per 100 grams, okay, so we can do that, common denominator, or we can look for the common denominator of 500 and 650. Okay, and then get dollars per and have the same. So I want to go to dollars per 100 grams. So $3.95. So if I want to make this into 100, I need to divide it by 6.5, right? There's 6.5 hundredths here. And divide this by 6.5, and what will that give us? So what's 3.95 divided by 6.5? Okay, so that tells you it's about 61 cents per 100 grams, right? $0.607. Okay, now how do you know to divide by 6.5? Just take this and divide it by 100, right? And you'll get what number you have to divide this by to get 100. Okay, and then with the other one, we've got $3 for 500 grams. So we divide by 5, because how many hundreds are there? There's 5 of them. And we get $0.60 per 100 grams. Okay, and that's likely what you would see in the store, right? You go to the grocery store, they're going to give you a list, or actually, they do it by milliliters probably, because yogurt's liquidy or semi-solid. Okay, so we can go to a unit rate, but we can recognize unit rates really kind of, wow, we got really small numbers there. Or we can go to a rate with a common denominator. Other choice would be to find the lowest common denominator of 650 and 500 and then just multiply each by whatever that number is. Okay. That's a little more difficult. Oops. That's a little more difficult. Hang on. It cost Jen $64.35 to fill her car with 55 liters of gasoline in Calgary. In Great Falls, Montana, the price per U.S. gallon is $3.23 U.S. dollars per U.S. gallon. The exchange rate is $1.014 U.S. for 1 Canadian dollar. Those were the good old days, right? I mean, it's not so much anymore. It's like 85 cents U.S. for a Canadian dollar. And there are 3.785 liters in a U.S. gallon. Where and by how much is the gasoline less expensive? So it's like, whoa, okay. There's lots to do here, right? So let's just break it down, right? I mean, if you just look at the whole thing, it's like, I don't know what to do, right? Like, there's way too many numbers in here. So let's just take it a step at a time. Cost Jen $64.35 to fill her car with 55 liters of gasoline in Calgary. So we can figure out how many dollars per liter, right? We get a unit rate for that. So let's start out with $64.35 per 55 liters. Okay, so what is that in dollars per liter? All right, calculator out too. Okay, what is it? 64.35 divided by 55. Okay, $1.17 per liter. Okay, so that's the unit rate. It's $1.17 Canadian for each liter, right? I mean, now we know it's like 91.9 or a little bit less. Okay. Now, in Montana, the price is $3.23 US dollars per US gallon. So we want to convert a rate of $3.23 US, so let's go USD, per 1 US gallon, 1 USG. And now we're going to convert that rate, okay? So here's how we're going to do our conversion. We need to end up with Canadian dollars per liter, okay? That's what I'm aiming for. So we're aiming for dollars Canadian per 1 liter. Okay, then we'll have the same rate. Okay, so I need to convert, so let's do this. We'll take US dollars, we'll put them on the bottom, and Canadian dollars, we'll put them up top. Now, there's a rate between US and Canadian dollars, and what is it? So 1.014 US dollars is 1 Canadian dollar, right? So they give that to us in there.
And $1.
Okay, so $1 Canadian is 1.014 US dollars. Now I get to cross off US dollars. So now I have Canadian dollars up top and US gallons on the bottom, right? And I want Canadian dollars in liters. So the top is good, right? The bottom, which is in, so I'm going to put a US gallon on the top and a liters on the bottom. So how many US gallons are there in 1 liter, or how does it work? So 1 US gallon is 3.785 liters.
Don't you probably want to get rid of on top?
Yeah, so what I want to get rid of is US gallons.
Yeah.
Okay, so what's left up top, right? I got dollars Canadian, and on the bottom I've got liters, right? So that's what I want, Canadian dollars per liter. Okay, so we do this calculation, so we take 3.23 times 1, okay, and divide it by, and I need to divide it by two numbers, right? So you can either do two divisions, go this divided by this, hit enter, divided by this, hit enter, or go 323 divided by bracket this times this, okay? Either one. So I'm going to do the this times this, 0.14 times 3.785. And I get 0.8415. Let's call it 842. Okay, so that's 0.842 Canadian dollars per liter. Okay, so there's a bunch going on here, right? First one, actually pretty easy, right? It's easy to figure out Canadian dollars per liter, right? Because we got $64.35 to buy 55 liters of gas. Boom, $1.17 per liter. Now we've got to take $3.23 per gallon. We got to get rid of the US dollars. So what you do is you put the thing you want to get rid of goes opposite. So I want to get rid of US dollars, I put US dollars on the bottom. And the thing that I'm going to convert it to, and they gave me the exchange rate, right? They gave me the rate, so I can put Canadian dollars up top. 1 Canadian dollar exchanges to 1.014 US. Good old days, right? Canadian dollars worth more. And then I want to get rid of US gallons. That's on the bottom. I put US gallons up top, and I want to end up with liters on the bottom, right? We know that because I want to have dollars per liter, Canadian dollars. So the US gallons cross off, and we've got 1 US gallon is 3.785 liters. Okay? You could walk to. One car manufacturer claims that the fuel efficiency of the Python car is 8.8 liters per 100 kilometers in the city. That's not believable. Any car named Python is going to use a lot more gas than that. The Cobra car has a fuel efficiency of 11.3 liters per 100 kilometers in the city. Which car is more fuel efficient? So Python or Cobra? Python? Why?
Because, wait, no. Oh, no. Yes, it takes less fuel to go the same distance.
To go the same distance.
Just exactly what she said. It uses less fuel to go the same distance, right? So all the Canadian car economies, if you look up the Canadian, car economy stuff, fuel mileage is always given in liters per 100 kilometers, right? How many liters does it take to go 100 kilometers? Another method or rate that some people use is miles per gallon, right? So we're talking liters per 100 kilometers. We're saying this volume of fuel to go this far. When we talk miles per gallon, we're saying you go this many miles on 1 gallon of fuel. Okay? So liters per 100 kilometers, lower is better, right? You're using less fuel to go the same distance, right? That's what we got here. Uses less fuel to go the same distance. Speaking of fuel. Jen has one of the two cars stated above. Jen drives her car until it is almost empty of gas. She notes that the odometer on the car states 12,789 kilometers. She fills her tank. She then drives for a week and fills the tank again using 29.5 liters. The odometer on her car now reads 13,125. Which car does she have? So we got to figure out how many liters did she use per 100 kilometers, right? So we know how many liters she used. She used 29.5 liters, and she went this distance. Okay, that's how many kilometers she went, right? Well, that's an expression. We got to actually work that out. So it's 29.5 liters per. Okay, so we got 13,125 minus 12, 17, 18, 9. You were late. Why don't you fill us all in on what's going on, just so that we can get on with the class? 336, right?
Right.
Okay, so how am I going to make that liters per 100 kilometers? So what am I going to divide by? 3.36, right? Now if you want to know what that number is, just take this, divide it by 100, right? And that'll tell you if I divide by 3.36, I will get 100 on the bottom, right? So now on the bottom, we got 100 kilometers, and up top, we have 29.5. 8.77, so let's call it 8.8 liters, sorry, liters. So which car does she have? The Python. So Jen has the Python. Yes, you're right, Hellcat is a way better name, but yeah, sorry.
How did you get
13,125 minus 12,780.
Oh, okay.
Okay. So what we do, I have an app on my phone, it's called Road Trip, and you just put in, this is the mileage, is what I filled it up as, and it gives you all the liters per 100 kilometers, and you can do little graphs and stuff like that. You can cry over the price of fuel. Problem solving involving rates. Johnny lives in the Netherlands, where transportation for one trip often means using a bicycle, walking, taking a train, and a bus. The graph below shows Johnny's trip from his home to meet a friend. So we have distance in kilometers, and we have time in minutes. Label each of the important points with letters, and then describe a scenario including the speed in kilometers per minute. Okay, so we're going to label, let's start with A, B, C, D, E, F, Y, and Z. No. G and H. You could have started with P, Q, R, S. You could have gone Z, Y, X, W, V, U, T, but that would all be kind of silly and likely to get you into more trouble. So what we're trying to do is come up with a scenario. What's happening from A to B? What's happening from B to C, C to D, etc., right? And we need to get a speed in kilometers per minute. Okay, so from A to B, what's A to B? So we want speed, let's say speed. A to B is going to be the distance. So you notice this A will be 0, 0. So he's going a distance of 2 kilometers. So it's 2 minus 0 in 6 minutes, which is 6 minus 0, which is 2 over 6, or 1 over 3, so kilometer per minute. Okay, so which of the following, bicycle, walking, train, or bus, could you be doing at 1 kilometer in 3 minutes? Probably bicycle, right? Okay. So he rode the bicycle, he rode his bicycle. He rode his bicycle. From A to B. Right? Now, as we figure out each of the rest, we'll say, okay, then he did, then his speed was this, so he got on the train, or he got on the bus, or he got on the whatever, right? So we want the speed from B to C. Yeah, so we're saying from A to B, rode his bike, and then things look like it's going pretty slow, right? Because he's gone 2.5 minus 2, so he went to 2.5 kilometers from to 16 minus 6, which is 0.5 kilometers in 10 minutes. So if you moved half a kilometer in 10 minutes...
Why do you do oh my God.
Okay, if you moved, then what were you doing?
Walking.
Walking pretty slowly, right? I mean, that's half a kilometer is 500 meters, right? So 500 meters in 10 minutes would be 50 meters per minute, right? That's moving fairly slow, right? So maybe he was in a lineup, right? And, you know, it's moving. So he gets somewhere, he got in a line. Okay, so rode his bicycle from A to B, then got in a line. And walked. Okay, so keep going. We got from C to D. We're going to run out of space here. That's right, smaller. Okay, C to D, so he's gone from 2.5 kilometers to 22.5, right? So it's 22.5 minus 2.5, and the amount of time that took was 25 minus 16, right? Because he started 16 minutes, ended at 25. So 25 minus 16. So that's 20 kilometers in 9 minutes. Okay. What type of conveyance is going to take you 20 kilometers in 9 minutes?
Bus.
So we've got taking a train, then the bus. So let's say the train, and walked to the train. Which he rode from C to D. Okay, then we want D to E. So D to E, right? So we're following the same pattern here, right? We're taking the difference in the time, so 34.5 minus 22.5. So I'm just going to write in the numbers here, right? I'm not going to put the calculations, because you've seen the calculations 3 times, right? So we're going 34.5 minus 22.5, which is 12. So 12 kilometers in 20 minutes. So 12 kilometers in 20 minutes. Okay. Now that reduces because they're both even, right? So we're just going to reduce. We're not going to necessarily take them to a unit rate, right? Now we might want to, because a unit rate you could actually compare them all, right? But we've got a pretty good idea of the comparison here. So 12 over 20, both divisible by 4. So it's 3 kilometers in 5 minutes. Okay, so what could take him 3 kilometers in 5 minutes? Probably a bus, right? Rode from C to D, comma, where you got on the bus. Okay. Oh, sorry, was that D? That was D to E. Where you got on the bus. Okay, what's happening from E to F?
He's at his friend's house.
He stopped.
At his friend's house, right?
Yeah.
So he is going 0 kilometers in 60 minutes. Okay, so the speed E to F is 0 kilometers in 60 minutes, or 0 kilometers per minute, per hour, whatever. Let's just leave it at that. 0 kilometers in 60 minutes. Okay, from E to F, we rode the bus D to E. From E to F, he visited his friend. Okay, F to G. So we got 34.5 to 2, right? Now this is going down, right? So here I would take the bigger number, 30. So if I go 34.5 minus 2, okay, we'll work that up here. So speed from F to G is 34.5 minus 2, so that's the distance, over 105 minus 125. So that's 32.5 kilometers in negative 20 minutes. All right, how do we get that negative? What's up with this negative speed?
You're going home.
Yeah, you're going home, right? So you're going back home So then you've got a relative to home, you have a negative speed, right? Because you're returning. So positive speed says you're going away from home. Negative speed says you're returning home. And we could do, yeah, okay, we leave that. And so he's probably riding the train home because it's moving pretty quick. And then we've got G to H is 2 minus 0 over 125 minus 131, which is 2 over negative 6, or negative 1/3 kilometer per minute. Okay, so we're back to the bicycle, right? So we rode the train, back to the bicycle, or back to the train station, got on his bicycle. So here, he probably got to the train station and had to walk in. Okay, and there's a big line of people waiting to get on the train, and here he gets back and he's on the other end of the train, so he's right at his bicycle and he doesn't have to walk, and then he walks home. Okay, so G to H is walking home. So this would be the train back home, and bicycle home. Okay. Convert the speed for the bus and the train to kilometers per hour. All right, so we've got the speed of the bus. What did we figure the bus was? Got a line, walked to the train, we got on the bus. D to E was the bus, and the speed was 12 kilometers in 20 minutes. So 12 kilometers, or what do we say? We reduced that, right? 3 kilometers to 5 minutes. How am I going to make that kilometers? How am I going to get an hour on the bottom? Okay, how many minutes in an hour? 60. How do I turn a 5 into a 60? Times it by 12, right? So what I want to get on the bottom is 1 hour. So that's equal to 36 kilometers in 60 minutes, or 36 kilometers per hour, right? So the idea is, let's change the bottom to be a 60 minutes. Okay, train going there. The train going there was C to D. I think we said that was the train going there, which was 20 kilometers in 9 minutes. So 20 kilometers in 9 minutes. So we're going to have to multiply by 60 over 9. Right? So 9 times 60 over 9 equals 60. So that'll be 1 hour. And 20 times 60 over 9. Okay, so we're going to get a decimal here. So 20 times 60 is 1200 divided by 9, 133.3. So 133.3 repeating kilometers per hour. Okay, that's likely the train. Not a lot of buses travel that fast. And the train going back. So the train going back was 32.5 kilometers in 20 minutes. So we'll ignore the negative now, right? We'll just say it's going 32.5 kilometers in 20 minutes. How do we get 20 minutes to be hours? Times 3. So we got 1 hour on the bottom. We got 3 times 32.5, which is 5. Carry the 1, 6, 7, 9. 97.5. 32.5. 97.5 kilometers per hour. A little bit slower. Okay, so we've got a scenario. We figured out all these slopes. The slopes were distance over time. Distance over time is speed. We got all these speeds. In general, 2 or more rates can be compared by converting the rates to unit rates, where the numerical value of the second term of each rate is 1, right? 1 hour, 1 minute, 1 liter. Or by writing the rates so the numerical value of the second term of each rate has the same value. So dollars per 100 grams, dollars per 100 milliliters. Okay, that's what you'll see if you haven't already seen. Everybody see the labels in the stores, right? If you look, Next time you're in the grocery store and you see a bunch of cans and stuff, look at it, it'll give you a rate of dollars per 100 milliliters, right? Allows you to compare. The slope of the graph relating two quantities represents the rate of change. So rate of change for the quantities represented. This rate of change is expressed as a unit rate. Dang, ran out of ink. No, ink's back. Unit rate. Okay, we could do that. So we did that for the bus and the train, right? Because it's hard to say, yeah, we have some idea if it's faster, but if we've got the denominators the same for all of them, whether it was 20 minutes on the bottom or 60 minutes, right? So unit rate, if we convert it to 60 minutes, it's per hour, that's a unit rate. If we converted everything to in 20 minutes, then we would have the same value, right? And we compare things as long as they have the same denominator. Rounding values allows for the something of rates of change. I don't know, what would go in there? I don't know.
Rounding values allows for the
Let's say comparison, we'll use comparison. It's as good a word as any.
comparison of rates.
I don't know. Honestly, I don't know.
Can you make on the answer sheet?
No, I don't even have the answer sheet, man. I'm just making this up as I go along. Okay. Next. I know, right? Solving problems involving rates. Okay, next page. 2 lessons a day, man. Push him. We gave you, I think we just gave you way too much time on that last year. We're oh, let's spend another day on this so that we don't panic and, yeah. That was easy, says the guy who scored well. He did, I noticed that. I thought, wow, it's a turnaround. Okay, interpreting unit rates. Each of the following unit rates are used in everyday life. What do they mean? 25 megabytes per second. PS. What's that mean?
I don't know.
What's it a rate of? Yeah, it's like a downloading or an uploading speed, right? It's the speed at which. So it's how we measure a rate of data transfer, right? So if you are downloading a file, you want to know how many megabytes per second or megabits per second, and that's how your computer can then give you an estimate of how much time it takes, right? Unless it's Windows, and then the estimates are totally.
3 years.
Yeah, it's exact. It does says that, right? It's 3 years. $1.20 per liter. Oh look, bird in the tree. There's a bird at the top of that tree. It's still a bird. $1.20 per liter. What is that a rate of?
Any kind of merchandise or liquid.
Likely.
Like, that's what you said.
Really? $1.20 per liter?
If it's
You're overpaying.
We're really expensive.
Yeah.
Okay, honestly, so.
What's usually $1.20 a liter? Gas, fuel. Yeah, it's 91 now, but if you try and get diesel, it's like $1.20 a liter.
I was gonna say water.
56 B per M. What is that? I have no idea. So come up with something. What's a B? $500 per week. What's that?
Allowance.
Yeah. I wouldn't mind an allowance like that.
That was Yi Yang last year.
Yeah. 9.81 meters per second squared. What's that? You know this. One of you knows this. At least one. This one. 9.81 meters per. Yeah, it's gravity, right? Acceleration due to gravity. 660 kilohertz.
How fast unit is?
Okay, that's cycles per second. It could be a sound wave. 20 psi. Pounds per square inch. Tire pressure. I don't know what takes 20, man. I can't think of anything that. Unless you're underinflating to get better traction or something, right? Unit rates help when trying to compare quantities. Okay, so we've seen that just on the last worksheet, right? If we can have a unit rate, it's easier to compare two quantities. One bakery offers scones for $2.60 the unit, however, cares not whether you like it or not. Yeah. I don't think the unit asked you for its opinion on it. What do you think of me, Laura? I don't like you. I don't like you already. I've just met you and I don't like you. One bakery offers scones for $2.60 each or $30 for a dozen. Another bakery offers similar scones for $3 each, but offers a baker's dozen for $31. Johnny needs 16 scones for the math meeting. Where should he buy the scones if he wants to spend the least amount of money? Okay, so 16 scones, right, means you can buy a dozen and then 4 more here. And a baker's dozen, what's a baker's dozen?
13.
Okay, so baker's dozen is 13. So we don't need a unit rate here so much, right? Like we don't have to figure out, we just figure out, okay, so bakery A, let's call it A. A, that's a 13, not a B. 13 scones. Okay, and this will be bakery B. So bakery A, we need 1 dozen. So that's $30. And then 4 scones, which is 4 times 260, which is what? 8 and 240, 1040. For a total of $40.40. Okay, that's bakery A. Bakery B, we need one baker's dozen, so we need 1 baker's dozen, which will cost us how much? $31. And then we need 3 individual scones, those 3 individual, which is 3 times $3, or $9, for a total of $40. So, which bakery should he buy from?
You should buy from
Whichever one is closest. Like, yeah, for 40 cents, I'm not going to make a trip. I spent $8 on gas to save 40 cents on scones. Okay, so yeah, unless you really like to shop and get the best deal, like I only paid $40. Yeah, dude, you spent like $2 on gas. You spent no bucks on gas. Because my car now tells me how much I spend on each trip. It's got a little. It's called a Mohijo plugged into the OBD2 port, so it can measure how far I've got. It's got a GPS, and it connects to the machine-to-machine cellular network. So it can tell you your trip started here and went here. This is how much gas you use. This is how much it costs.
Is that your STI?
Yeah. Well, it's a thing that plugs into the STI called a Mohijo. Okay, go back. Okay, so where would you buy at the closest bakery? Because for 40 cents you're not gonna. But the math answer would be bakery B.
Is that 9 or
9. You just gotta figure 31 plus what is 40. So then it's gotta be a 9. Not the best rating. But come on, we gotta get through 2 of these. We don't have much.
That's a lie.
Okay. Students' Council is ordering pizza. All right, at least it's just this one page, right? For the volunteers at parent-teacher interviews, they estimate they will need 2.5 slices per volunteer. There are 52 volunteers, and each pizza has 8 slices. How many pizzas should they order? Okay, what do we do? Don't say math. I know we do. What math do we do?
Go to that.
So what's the first thing you got to figure out?
Wait.
Yeah, 52 times 2.5. We need to know how many slices do we need, right? So we need.
It would say that you have 2.5.
Okay, so what is that? 130, right?
Yeah.
Do the math. 130.
And then divided by 8.
Yeah, and there are 8 slices per pizza. So 130 slices divided by 8 slices per pizza. So the interesting thing, when you're dividing by, you see slices and slices, and you got the per pizza on the bottom. These cross off, and this flips, so it'll become pizzas. Okay, so what's 130 divided by 8? 16 point what? 25 pizzas. So how many do we get? Yeah, they get 16 and somebody gets shorter today, you just figure, you're not gonna all eat whatever, or you get 17 and you have some left over, right? So that's a decision that you have to make. Leftover pizza. That's always good cold in the morning. Yep. Okay, so how many pizzas? 16 or 17, depending. Ms. Dessens and her husband ride their bikes on wind trainers set up in their basement. This is actually true. Ms. Dessens can burn 500 calories if she rides for 55 minutes. Her husband burns 400 calories in 35 minutes. Ms. Dessens rode her bike one Saturday morning and burned 875 calories. How long did her husband ride in order to burn the same number of calories?
Oh my god.
Yeah, I know. That's one of those oh my god questions, right? It's like, there's so many numbers and stuff. So what do we have to figure out first? Yeah, let's figure out the unit rate at which she burns calories, right? So what's the unit rate at which she burns calories? So what does she ride? She does 500 calories in 55 minutes.
9.09090991.
Wait a sec, do we even need this number?
No.
Not really. We don't, right? We don't need this. It was a good start, but we don't need it. Okay, what do we need? We need the husband's rate. Okay, so husband. Husband burns what? 400 calories in 35 minutes.
11.42.
Okay, so 11.42, 8, 7, right? We're going to need that number. We're just going to keep it in the calculator, right? And I'll show you a different way to do this in a second. So that is calories per minute. So what do we do with the 875 in this number? So if we take 875 calories divided by the rate of calorie burn, calories cross off and the minutes flip up. Okay? And what do we end up with?
76.5624.
So we would round accordingly, right? Nearest tenths, nearest hundredths, nearest minutes. If in doubt on a test, if it doesn't say, just round it to the nearest hundredth. Okay? And the final exam, we make sure that it actually says, so there's no doubt. You're not sitting there going, I don't know what to round this to. It'll say. Okay, so there we go, 76.56. Now another way you can set this up is say 400 calories in 35 minutes is equal to 870 calories in X minutes, right? Because we want to solve for this. And then we can cross multiply and divide. So we can say 400x is equal to 35 times 875, or x is 35 times 875 divided by 400. Okay? So you can set up an equivalency, calories per minute to calories per minute. You know 3 of the 4, you can figure out the 4th. A little bit of math, right? So either way, the unit rate, and then in this case divide it to get the minutes, or set up an equivalency and solve. Okay, 2 more. Johnny searches through the Google to determine the driving distance to Vancouver. Google states that the driving distance from Calgary to Vancouver is 9. Yeah, you might want to use DuckDuckGo if you're interested in your privacy. And you won't get all these ads for whatever it is you last looked up. DuckDuckGo. DuckGo. It's a default search engine in Safari now. You can choose it as one of the defaults. DuckDuckGo doesn't track you. You notice how you use Google, and if you looked up some product, it appears on every single page you look at, like for months. So they're just targeting, right? It's like, well, you looked up this thing, maybe you want to buy it, and so every ad you see, and then people pay Google money to put that ad up there, right? I mean, your friend, say, at the computer next to you, having searched something different, is now looking at a whole bunch of whatever, rims for their STI while you're looking at, headphones or something. Louder.
Yeah, you're in your car, right?
Yeah.
Yeah, rims for an inspection.
Yeah, rims for your STD.
Okay. That doesn't work.
All right, anyways, what do we got? 972 kilometers driven in 10 hours, 37 minutes. Johnny decides to make the trip and assumes that all the Google states is true. Determine his average driving speed in kilometers per hour. Okay, first, 10 hours, 37 minutes must be converted to hours. So it's 10 plus 37 over 60. Okay, so we need to convert 37 minutes to hours. We convert minutes to hours by dividing by 60. So because we need a decimal number of hours, right? So what is that? 37 divided by 60 is 0.616 repeating. So it's 10.616 repeating. Okay, I'm going to leave that, right? I got this in mind. I'm just going to add 10 to it. So in my calculator, I have 10.616666666. I want that number. His driving speed, so we've got 972 kilometers divided by 10.616 repeating. So I'm going to go 972 divided by, second answer, pull that down, I get 91.55 kilometers per hour. Okay? The fuel efficiency in liters per 100 kilometers of Johnny's car if it used 85 liters of fuel for the trip. Okay, so we used 85 liters. We want liters per 100 kilometers, right? So 85 liters, how many kilometers did that get us? 972, right? How do I turn 972 into 100? Divide by 9.72, and you want to do that for both. Okay, so we get 85 divided by 9.72, which is 8.74. We'll go to the nearest. So 8.74 liters per 100 kilometers. Okay, not too bad. It's not in hybrid territory or anything. The average price in liters, or the average price per liter of fuel in dollars per liter, if Johnny spent $124.67. So we got $124.67 for how much gas? 85 liters, right? Okay, so we just take 124.67 divided by 85 is 1.47, rounding to the nearest, because that's what we round to, dollars per liter, right? Dollars per liter. Yep, that's expensive. It's even above premium gas. Okay, one more. Ellen, get from the box.
Shane, show everyone your
The scale. Massive scale. All right, last one, right? Let's do this. Scale on a map is 1 centimeter is very, coming to the final that way, though you'll make sure you have something the right way. Scale on one map scale on a map is 1 centimeter is 20 kilometers. If Calgary is approximately 50 kilometers from north to south and 35 kilometers from east to west, then determine the area of the map representing Calgary, assuming Calgary. So we got this rectangle. And we say it's 50 kilometers this way and 35 kilometers that way. Okay? Now, on the map, 1 centimeter is 20 kilometers. So how many centimeters? How do we get how many centimeters this is? So on the map, how many centimeters is Calgary this way?
How many centimeters is 1 centimeter is 20
do you multiply by 20?
Divide by 20.
Divide by 20. Okay, so we want 35 divided by 20, right? Because 1 centimeter on the map would be 20 kilometers, 2 centimeters would be 40, so we know we're between 1 and 2, right? So if we try and multiply 35 by 20 and get like 700, you're going to go, that seems a little large if 2 centimeters is 40 kilometers. Okay, so 35 divided by 20, 1.75 centimeters. And this one will be 50 divided by 20, which is 2.5 centimeters. Okay. So on the map, Calgary will be 1.75 by 2.5. So the area which is how much? 4.375 square centimeters. Okay, and I'm not going to, I didn't say any rounding, so we'll just leave it, it's exact and it's not like a horrendous decimal, right? It doesn't go on forever. Population density in people per square kilometer if Calgary has approximately 1.2 million people. Okay, so we've got 1.2 million divided by, the area will be 35 times 50, right? Because that's the actual kilometers. It's 35 kilometers wide and 50 kilometers long. So that's 1,200,000 divided by 1750, right? It's got to be 1750. Okay. So 1,200,000. 685.7 people per square kilometer. If you want something interesting, look up the housing density in Hong Kong or New York, or like the area of New York City, including the 5 boroughs, blah blah blah, is probably somewhat bigger than Calgary, not horrendously larger, but they have a much larger population, right? So population density. So there's a lot more high rises in areas like that, right? If you have a lot of high rises, you're going to have a lot higher population density, right? Calgary does not have a lot of high rises. Like outside of downtown, which we can see out the window. Well, not really.
I can.
You can sort of almost see out the window. Yeah. Okay, last one, and then a mess trying to get videos going. The drawing in a biology book of an ant has a length of 10 centimeters. If the actual ant is 4 millimeters long, then determine the scale. So what scale? Scale is, oh, what's yours?
2.5
2.5.
centimeters.
Oh, God, we made it so easy. Well, it's really easy now. So, scale is what?
It's 4, because you divide by 4.
Okay, so we think of scale, think about a map, right? So 1 centimeter on the map is 20 kilometers. So scale is the measurement to real life, right? So the real thing is the second thing. So scale is a measurement of measured to real, right? So we've got 10 centimeters to 2.5 centimeters, which is 4 to 1. Okay, so that's blowing up, right? 4 to 1 is making the representation is 4 times the size of the real thing. Whereas 1 to 20 is scaling down, right? So 1 centimeter is 20 kilometers. So 4 to 1. Scale factor is generally expressed without units. Okay, so we say 4 to 1. For what? Well, 4 millimeters on the diagram is 1 millimeter in real life. 4 centimeters on the diagram is 1 centimeter in real life. Okay.
So if we get the scale where we take the units out, then it's just 4 units to 1 unit. Okay, now, are we done?
Yes, sir.
Thanks. Yeah, it's a little foggy.
So much haze out there, right? All right.